Hello students, welcome to Education. This video we are going to discuss about topological sorting or topological ordering. Before starting it, those who are new to this video, kindly watch the previous video which is about depth first sorts because we are going to utilize the DFS or you can say the approach of stack data structure here in topological sorting. You can ask me why topological sorting we should start or why topological sorting that we should read. The main reason with the real life implications, if I'll say, or implementations, if I'll say, you can say whenever the IBs, like intelligence bureaus or some intelligence agencies, or might be police, or like what the agencies are like to investigating agency, you can say in total they are actually pointing the problems which are related to the previous problems or the coming problem, like they point it and they are just connecting it to find the source of the problem. What they have to do, like they might be started from somewhere, like from the starting end, from the ending end, like from the end to start or start to end, like they have to find a clue. Basically these dots are basically the clues for a particular problem. They are trying to resolve that one in a particular order, in a sorted order. You can say another example is, suppose you are right now reading algorithm design. Before that, what are the prerequisites? To get the prerequisites, to have the prerequisites knowledge first, we have to read data structure. Before that, also what are the needed subjects or record subjects are certain languages like C, C++, Java, Python, any language you have to read first. Then you go for the implementation of data structure. Why data structure is needed, that we know, to structure the data, upcoming data, or might be to store the data. We have certain structure, like how we will store it. To storing that purpose, we are using it. Next, for algorithm, what we are actually doing in algorithm, we are effectively storing that one, as well as whenever we are searching, whenever you are finding the data, that case we need effective time. Instead of suppose 10 seconds, if you'll get it within 5 seconds or 3 seconds, that is what the algorithm will help you. So these are the prerequisites. When you reach, like as I told you, sometimes like this video for newcomers would not be possible to understand directly. Better you can go to the previous videos where the elaboration could be there in the previous video. Like as I told you right now, topological ordering is based on a DFS. To know that, you can check the previous videos. So this is what actually the structure is. You can start from this structure, this order. Definitely it will sort all the problems. Okay, this is how topological sorting is all about. And real life implication, it's too good to implement in real life problems to solve it easily. If a big problem is there, you just find the clues, you just connect the dots, which are the clues, you can say. Let us think for a while, where we have a problem and we have just certain clues, we just connect it with. When we start with the problem, we start with the order. If you get the order to get the resolution of each clues, then we'll reach to the solution indirectly. Okay, each clue is a partial solution for these steps. Clear? For getting the solution for a problem, the biggest problem which we select for a while. So now we will discuss how topological sorting and topological ordering is working. Okay, so this video is all about the sorting techniques using the graph, which is topological sorting. So I am following two books here to make this video. I am following two books. One is Tadas, which is the name of the author, Eva Tados, where you'll get algorithm book. It is widely used. Another book that I told you repeatedly, which is Corman. So the name of the book is they are the authors. Tados is the author. She is might be a professor, and Corman with other co-editors or authors have written the book named as Introduction to Algorithms. So here in this book, what actually the content is, in Tados, it is written that when we start, as for this, these are the pseudocodes written for this algorithm. To compute a topological ordering of tree, like what we have to follow the steps that I told you, these are pseudocodes. Find a node V okay, node, or you can say vertex V with no incoming edges. Okay, no incoming edges means we are focusing on in degree. Okay, as we have already discussed what is in degree, also we will discuss here in degree. And order it first you ordered it. If in degree is 0, if in degree is 0, then you have to order it first, means that will be ordered first. Next, which one you have ordered, that you have to delete one by one. Once you are deleting, you have to delete the connected edges too. Once you are deleting the connected edges, the next in degree could be changed to some, like the next vertex which are connected to the deleted vertex will have the change of in degree concept or the in degree values there. Next, recursively compute a topological ordering of G minus V, means which you have selected. You have to remove from all the vertices present in that graph, and in that graph you have to remove. This is what it says. From the graph you are removing means G minus a small v. Otherwise, it could be like V minus V, which represents you are actually removing from the vertices. We are not actually removing from the vertices, we are working on the graph itself. That's why we are, instead of V, we are writing G. Okay, now, and append this order after V. Clear, no? So we need to append it once it is completed. After that we will write that. This is the meaning of it. Okay, after the deleted, the next deleted will be written after the V, okay, which was previously deleted. So here in this example, you can first write the integers. Whenever we are writing the solution, yeah, this is the graph. First of all, we will write the integer. Integer means inwards, like from anywhere, but towards the node. मान लो कि तुम्हें कोई गोली मार रहा है, it is onwards, it is towards you. So in degree, if in degree is not 0 means somehow you are actually facing the problem. गोली तुम्हारे तरफ से आ रहा है तो in degree is 1 now. दो गोली आ रहे हैं, ऐसे दो गोलियां आ रहे हैं तुम्हारे तरफ तो in degree is 2 now. 1 in degree is 1. If nothing, no one is actually firing towards you, so definitely it's 0. This is in degree. Out degree means तुम मार रहे हो किसी को, तुम्हारे साइड से जा रहा है. This is out degree. Clear? So here there is no such directions towards V2 is 0 now. In degree is 0. I'm just writing in degree. Okay, in degree. Not repeatedly I'll write. I just think the above one is considered as in degree. Okay, in degree is 0 now. Next, V3 only one in degree is there. Why? Because from this end we got 1. Okay. Next, what for V4 there is one another, so 2 in degree. Here no in degree. Here also the in degree is 3. Here the in degree is 2. Here the in degree is 1, 2, 3, 4. Clear, no? So first you have to write the in degrees. Next, what you have to do, as for this ordering, as for this status, they said in degree 0 will be deleted first. So here I am writing the steps to make you clear about it as per the book. Step 1 says in degree 0, in degree 0 will be selected first. Okay, selected first. In degree 0 will be selected first. Step 2, delete the selected vertices or vertex. Clear, no? And 3 is repeat. Next, third step is update the in degrees of all vertices after deleting the selected vertex. Once it is done, okay, Step 4, repeat step 1, 2 and 3 until all vertices have been have deleted. You have to repeat step 1, step 2, clear? Next, step 5, you have to, or you may write it. Either you have to write in a, you can say just putting a comma, or you can keep in an array. Okay. Now in degree 0 here v1 we have deleted. Once v1 is deleted now, so here in degree is 0, here in degree is 1, here in degree is 1, now in degree is 3, now in degree is 2, in degree is 2. Clear? We have to update. Here I have written the steps to make it easy. Okay. Next 6, like the 0 will be deleted, so 0 we have deleted that. Once we have deleted it, we will get we have to write again the, uh, you can say the in degree. Here the in degree is 1, here the in degree is 2, here the in degree is 2, here is 1, here is 0. Now v3 will be removed. So in that case, whenever you are writing, you just write the result, you just write the topological sort, topological sort or order. Okay, so I'm just writing, once I'm deleting v1, so I'm just writing v1 as per the A. Next v2 will be deleted, which has already been deleted. Next v3. Okay, whenever you are deleting, you just maintain that array. So always topological sorting could be possible in, as one it's not possible. So topological sorting could be more than one. Okay, like here the example, we can start from v1, you can start from v2, not an issue. You can start from v2, then you can start, you can change the v1, because the in degree 0 will be considered as to be deleted first. Okay, so here as per the book they started with the v1, you can start with the v2, not an issue. But always remember that should be directed acyclic. We will discuss that one later. Okay, so here this happened, not an issue. Clear now? So we will be deleting that one. Next, once we'll delete, we just write it. In the D section, we have to write it here in degree is 1, here in degree is 2, here in degree is 1, here in degree is 0. Now V4 will be deleted. V4 is deleted now. You come to E, here V5, V6, V7 is there. So first you write in degree is 0, here in degree is 1, here in degree is 2. So the lowest will be deleted first, lowest is here 0, and we should start with a 0. No need to worry about any 1, 2, 3. 0 will be deleted first. Clear? As per the, as per the thing written here well. Okay. Next is V6. So here once you delete that one, you write that there. Next v6, here 0, here 1. So you can write v6, then v7. Okay, this is the sorting you can write. This is one sort that I have written. This is not always correct. You can write v2. You can change that, and based on the changing of the nodes, means deleting of the node, you are creating indirectly another topological sorting you're writing, and also the graph is also being getting changed. Sometimes you are getting, like if you are deleting this one, so instead of 1 that could be have 0, like v3 and v1, again two options could be there. So probability is there. Infinite number of topological sorting could not be possible. More than one could be possible. If infinite, so you cannot define the time well. Definitely the problem is there in an algorithm. Okay, might be we have to change certain things. So here we have to write the steps which we have written. As per the steps, we'll get a topological sorting. Next is, like here, I told you the next book which is written by Corman and co-authors also. So in this book, Introduction to Algorithms, here they started with the stack implementations. Here no stack we have used. Basically, we have to follow certain steps. Here in DFS, we have to follow certain steps. Like as for the DFS, it is depth first search. Like we have to reach towards a particular node through a direction, particular directions. Once we reached it, then we get backtrack using the stack. That is why DFS is getting used. Here in this DFS, we will call the DFS program in the or algorithm. In this DFS is written the finishing time of each vertex. First of all, we have to check like how many the connections could be possible for each vertex is finished. Insert into the front of linked list. Next, return the linked list. of vertices. Don't worry, I'll run this one. But as for the steps is they're written here, I'll not follow that one. I'll follow first the simplest one. Then we'll back to the steps written here. Okay. By the way, this program, sorry, this question I kept from Gigs for Gigs, but I'm not always following. I'm always watching the contents. But I found somewhere the mistakes are there. To rectify the mistakes, I have created the videos. Okay, so do not blindly believe on someone. It's my request. Try to read the books. If you have any problem, try to ask me directly, because through the channel I am connected with you people. Might be I'm not physically available, you can directly contact through the any channels, like comment below. You can directly get me back to any LinkedIn profile, any profile. Don't worry about it, because you are learning the things. Learning should not be blind. It should be some proof that you have. Like I'm following the book, that's why I'm writing it. Wherever I'm following, I'm just saying it clearly. So not an issue. Now we are going to solve it first. So I'll be starting with my steps first. Then based on our step, once we're done with it, then we come to this step. Okay. The same example I'm writing now. Example previously we have gone for the example, previous example. Now it's the second example, you can say. I'm just writing it example 2. Here in example 2, 5, uh, first I representing the node. Okay, once I am representing node, then only we can be discussing well about the steps. I'll write the steps also, which will clarify your doubts too, or might be give you the easiest process to work on. Here there is a node connected. Now it's 5. Okay, it's 2. Now it's 0, and now it's 4. From 4 we are getting a connection. Now 1. Now it's 3. Clear. Next is 1. Clear. So first of all, what we have to do as per the steps, step 1, I'm writing S1. Okay, step 1, create 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 or build the adjacency list. Create the adjacency list of the given graph. Clear. First we have to create the adjacency list. Based on the adjacency list, what we have to do, if no outages, clear, means from a particular node, if there are no such connections are built up, we will be selecting that one. After that we will delete that one. Okay, so in step 2 I have to write no out degree, or out degree 0 will be selected first. Out degree, it is not written anywhere. I'm just saying the steps which will be clarifying your, any kind of biggest problem could be solved using these steps. So I'm just writing my steps, which is the gist of the theme which I have read till date. Okay, might not be available anywhere, I can guarantee you this. In these steps, out degree equal to 0 will be selected first. Next step 3, delete the selected nodes or vertices, but one by one. Okay. Next 4, once we are done, next out degree, like from lowest to highest, delete the other nodes by, we have to select which has been deleted and there as out degree. Delete the other nodes which are You can say delete the nodes in increasing order. That could be better. Nodes in increasing order of delete the other nodes in increasing order of out degree. Okay, like increasing order of out degree will be deleted one by one. Prefer what we have to prefer? Prefer prefer a subpoint. Prefer the nodes or vertices which has been which has deleted or which vertices we have written which have deleted already deleted and connected with the upcoming nodes. Prefer the nodes or vertices which have already deleted, which have a connection with the connection with already deleted nodes. Already deleted, that could be better. Prefer the nodes or vertices which have the connection with already deleted nodes. Deleted nodes or vertices. Clear? So prefer that node, prefer prefer the nodes or vertices which have the connection with I'm writing it clear, connection with already deleted nodes or vertices. Clear? Step 5, repeat step 4 until all nodes or vertices have deleted or removed. Clear? Once you have done with it, clear? Once you have done with it, what you have to do? As per this, you are storing in the stack. Clear? I'm just writing that one. The stored vertices, the deleted vertices which have been stored, the deleted vertices which which have stored which have stored in the stack will be printed स्टैक में जो है उसको हम प्रिंट करेंगे. देयर आर six steps I have written. First we have to create the adjacency list of the given graph. Next, out degree 0 will be selected. Delete the selected node or vertices. Next, delete the other nodes in increasing order of out degree, basically basis of out degree in increasing order of out degree. Clear? Next is prefer the nodes or vertices which have connections with the already deleted nodes. We have to prefer that one while deleting. Okay. Next is repeat step 4 until all nodes vertices have deleted or removed. Then the deleted vertices which have stored in the stack will be printed. Okay. So let us start with this example. The same example which we have written, or we should say its solution. Okay. For this 5, you start either from 0, 1, 2, 3, anywhere you start. Suppose as for this, I am just starting from 0. Okay. Better, adjacency list, it will be written like this. Okay. So 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, then 5. There are 6 nodes. Okay. Based on their connections, we are now writing the, like, from 0 there is nothing, from 1 there is also nothing, 2, from 2 to 3 there is a possible connection, as here also you can check. Okay. You can write from 2, here we have 3, and we should stop here. From 3 we have 1, and we stop. From 4, here is 0 or 1, like you can write 0 at the first or 1 at the first. I'm just writing 0 at the first. Okay. Next, this one is connected with 1, or else you can write 1 first, then 0 at the last. For the 6, for the 5, sorry, here the 5. So 5 is connected with 0 and 2. You can write 0 the first, or 2 could be the last, not an issue. So I'm writing 0 and 2. It's up to you. You can write 2 first, then 0, not an issue. So adjacency list is done. So first step is done. Next, outer 0 will be selected, and that selected will be deleted. Once we are deleting, we have to write what? You just check it. As for this topological sort 0 visited, we have to visit it. If it is true, then we should say we have completed. Okay. As for the stack, first of all, we will store in the stack. Okay. So step 1 in the first is topological sorting, logical sort. This is just an algorithm. We started with 0. Okay. Once it is there, visited true. As it is written, visited, here it is true, or else you can write we visited 0. Here the next it is written as list is empty, means after that nothing is connected, no more recursion call. Okay. I'm just writing that one, list is empty, no more recursion call. That means after 0 there is no such, uh, you can say, nodes or vertices which are connected to the 0. So no connections. We simply store the value which is being visited as true for the time being. Okay. Either in a vertical you can store as a stack, or in a horizontal way also you can write. Now, second, uh, out degree 0 is 1. Out degree means from, like, how many arrows you can, you know like, as I told you, कितना गोली तुम मार सकते हो. From your side, how many firing that you can do. You are doing the fire means definitely you are doing the out degrees. Towards you, it's in degree. Okay. Now topological sorting, you can say, like, I'm just writing it by keeping this as hint. Better I'll write 2 times or 3 times. But then I'll do that one. Topological sort I'm writing as 1. Now I'm giving visited, 1, then we should set true. From 1 there is no such connections being established, so we are writing that least. Okay, no more connections could be established. So then we are storing that in stack. The value is always in a stack. After completion of the nodes, we will print it. Print means popping out in last in first out manner. Okay. So next in 3, once it is done, as I told you, like increasing order could be better. So prefer the node which is connected with the previously deleted. Here 2 and 3 will be selected. Why? Because only one out degree is there. Here others are having 2 out degrees. Do not be confused. Why I'm picking that? The main reason is we will stop somewhere. Clear? We'll stop with a with its list now. So once I'll tell you, like 0 is visited, 1 is visited, which is being stored here, or which is being deleted. So the connected is 3 is not yet deleted, and 2 here is for 3, the next which is 1 is already deleted. So in this case what you have to write, you remember topological sorting. I'm just using 3. You can write 2 directly, not an issue. For the 2, some little changes we have to do, which is there in an example. Okay, so I'm just writing it topological sort, which is 3, that we started with 3, visited 3 equal to true. Then from 3 there is a connection to 1. Here you can say 1 is already visited. Here you can check that as per the example, 1 is already visited. No more recursive call. No more recursive call. Recursion call. So once it is done, so in the stack what we have to write? In a stack we have to write the same value 0, 1, then 3. It will be very much easy or convenient for us to understand it. Next, it is done. Okay, next we switch to 2. Why? Because 3 is already moved. Then we will pick, it is preferable, you can start with the 3, not an issue. If you start from the 2, for this 2 what you have to write also, that I'll discuss, don't worry. Next 4, here topological sorting you have to write topological sort. Okay, so 2 now I'm writing, and here visited 2 is true now. And here in this case what we will write, though 3 is already visited means it's there in a stack means it's already visited. Okay, so you can write 3 is already visited, so no more a recursion call or recursive call. Okay, then you can say stack could be written as simple 0, 1, 2, then 3, 3 then 2, sorry. Why? Because up to that we have written 0, 1, 3, then 2. 2 we have recently followed. Okay. Next, when we are selecting this one, so the connected like 4 and 5 already the connections have been established. Like you can say 0 is deleted, 1 is also deleted, 0 is deleted, 2 is also deleted, means visited, you can say. Okay, already visited. So up to this all are visited, so no need to worry about taking any of could be possible for us. Let us go for the 4. 5 could be written, not an issue. This is how it's easy. We are going for easier way. Okay, that's why I'm writing the steps. Otherwise I shouldn't write the steps. Topological sort, I'm writing it. 4 you can write, 5 also not an issue. So now I should say as visited 4. Let us say this is true. Okay, for that then you can say 4 to connection is 0 and 1, so you can say 0 and 1 are already visited. So no more recursive call or recursion call. Okay? So this is how we are actually planning to have, like 0 1 is already visited, so no need to go for any recursion call. So you can say stack could be rewritten as or could be updated as this much, like 0 1 3 2 and then 4. Okay, so this is how we have clarifying our uh, the nodes which has been uh, deleted. Now 6, you write only one is there, topological sort. 5, visited 5, true. Then in that case 5 is connected with 0 and 2. 0 and 2 are already visited. Clear? So no more recursion call. Clear? So you stop now. Once you are stopped here, so you have to maintain the stack as per this order: 0 1 2 sorry 3 3 then 2 then 4 then 5. Clear? But this is not the end, you need to print it. So seventh is, as we have written here, the step 6 we have to print it. So here print the stack. When you print the stack could be written as, though I was writing in this way, better I'm just writing it. Here you can check: 0 1 2 0 then 1 then 3 then 2 4 and 5. I make it in a vertical line because you know it's very easy for you to understand. So once you print it, means you are popping out the values. Pop pop function you are running. Okay? So the answers you are writing could be like in an array. If you're storing, it will be 5 4 2 3 1 0. This is the answer. You can say it's a topological sorting. Clear? So you can check whether it is correct or not. To check that one, you can use the Tados one. That could be better for you to understand. I'm just doing the Tados here, which will clarify your doubts. Tados, I'm just writing it Tados. Where in degree is considered as 0 will be deleted first. 5, to verify that one, whether what I have written is correct or not. So I want to check that one. Okay. Here the connection is 4. Next it's 2, then 3, then 1, I think. Yeah, it is 1. Yeah, 1. Clear? So here the in degree, I'm just changing the color. In degree, verify that one. Okay, here in degree is 0, here in degree is 0, here in degree is 2, here in degree is 1, here 1 and here 2. So as per this, 5 will be deleted. Suppose let's delete the 5. Topological sorting, sort or order. Clear? So in this way, suppose 5, you have to delete 5. No need to change, but update it now. Update that as 0. Okay, and here update this as 1, because here it is deleted. Clear? So then no need to update anything which are connected to it will be updated. Here 4 will be deleted, and if we'll delete this one, instead of 1 it is 0, instead of 1 it is instead of 2 it is 1. Now you need to delete 2. Clear? 2 here it is also being deleted, able to possible to delete this one. Once we are deleting, 3 will be 0. Yeah, this one we have to match. So here 3 could be deleted. Once you are deleting 3, you have to delete this, which is 0 now. 3, 1 could be written, not an issue, and here the 0 could be written after this. So in this way, we can verify it well. The topological sorting could be possible using DFS, which is being written by the uh, Corman, and through Tardos we have verified it. Yes, this is working fine. Okay, and the other approach which I was telling, like this started with 0, so 0 will be written here, then 1, not an issue, then they started with a 2. When they started with a 2, 2 is connected with the 3, so 2 is not visited, so let's say it's true. Next, 3 is also not visited, that's why you have to visit it. But when we reach 3, but 3 is connected with 1, the 3 is connected with 1, we should say 1 is already visited. That's why what we have to do, we have to do in this direction. Once we reach at 1, we have to insert. Whenever we are inserting, we have to reach in that way, insert. So 3 will be written first, then 2. This is how I didn't told you this first one. The first step, as I have to follow my rule. Once it is done, then I am following the steps for how they have written. So they have to do one by one. Once it is done, the what they have done, like for insertion, it will be from low to high. Okay, from the last to first. Then for 4, 1 is 0 and 1 already visited, so they have written this step also they have written, and step 6, print all the elements from top to bottom, means pop out the thing. Next, as per the note, okay, as per the note, I'm just writing, highlighting this. As per the Tardos, in degree 0 will be deleted first. Clear? As per the Corman, out degree 0 will be deleted first. This is I have written to gist it note, but there is no such where you they are mentioned. Okay, out degree anything could be deleted, but I have written to make you a easy solution. For easy solution, I'm writing it for easy solution. For easy solution. Okay, for easy solution, I'm just writing it out degree 0. But out degree concept is there in Corman, in degree concept there in Tardos. Stark data structure is used in topological sort or order. Okay, the time complexity is the same time complexity as the DFS have, but that we should say implementation topological sorting is sorting or order is the implementation of DFS, depth first search. Okay, next is time complexity. Time complexity is big of V plus E for adjacency list, and V square is for adjacency matrices. And for space complexity based on the adjacency matrices, you can say v square, and for the adjacency list is v. So in this way, I think you have understood how topological sorting is working, how stack is helpful, and how DFS is helpful also. So thank you for watching. Have a good day.